Hi and welcome. In this short video, Akshay and I, Edwin, will be showing you how we use GE's Predix to enable the Industrial Internet of Things. Specifically, we will talk about the use case of using machine data generated by a Raspberry Pi and an Edison board to perform analytics. In a real-life scenario, the data will come from a CNC machine and then the analytics used to produce outcomes such as manufacturing optimization and productivity gains. Both Akshay and I are SDM fellows at MIT. SDM stands for Systems Design and Management, a program jointly offered by the Sloan School of Business and the School of Engineering. This video is part of a project for the class of Engineering and Architecting the Internet of Things, directed by world-renowned professors Abel Sanchez and John Williams. Let's get into it. Connecting manufacturing equipment into Predix is part of GE's Brilliant Manufacturing solution. Brilliant Factory is about applying many of the advanced manufacturing theories. Manufacturing, especially for high-speed manufacturing, whether it's automotive or food and beverage or CPG, or some of the large turbines, is reasonably advanced in that they've done a lot to optimize the supply chain within the manufacturing aspect. However, what we are looking at today is optimizing all the way from product design through manufacturing, through the supply chain, and even into service and repair. And we talk about this in terms of connecting the digital thread between the different systems so that as you design your product, it's designed for manufacturing. The digital thread is about connecting machines, data, and people to make better business decisions. So what's in the Brilliant Manufacturing suite and what are the primary outcomes? The overall suite optimizes factories and supply chain to improve production capacity, maximize uptime and asset return, and reduce running costs.
Predix architecture has three main components. Connectivity, that is the component installed on machine that pushes the data to cloud. Cloud services, it's a suite of microservices already available in Predix, which we can utilize to build services. And applications, web applications that leverage the microservices and data to visualize or perform analytics. So for connectivity in our project, we installed software components on the Raspberry Pi and connected multiple sensors to it for data capturing and securely streaming it into Predix Cloud. Predix machine is made of Linux shell scripts, Java programs and libraries, and frameworks provided by Predix, some open source and some copyrighted by GE. For cloud services, we utilize three main services from Predix. UAA, that is user access and authentication. UAA will manage the client control for connectivity from Raspberry Pi and the user control for access to the app. Time series, also a part of Predix catalog. This service is used to efficiently manage, distribute, ingest, and store time series data. Time series is ideal to manage data from continuous streams of sensor information since it maintains the arrival time of each stream and indexes it for faster queries. Asset, part of Predix catalog as well, this service is used to create and store asset models that describe machine types and to instantiate representations of such machines. After we had the infrastructure in place, we built a Predix application, a simple front end on its web domain, to visualize the data captured from Raspberry Pi. So, moving on to the demo, this is the login screen to access the web application. The key thing to remember here is that the authentication, user management, and keys are all managed by UAA, which is a Predix microservice. So once we log in, we get a dashboard where we can select the time duration to see the data. First graph is from the light sensor. We can see data on x-axis and the sensor activity on the y-axis. Second graph is from temperature sensors, a very similar view. Data on x-axis and sensor activity on y-axis. We had two more sensors, rotary and button, and we can get their data in the last view.
So, what did we learn today? Predix is a great environment. An out-of-the-box microservices-based architecture makes things much easier with a high level of reusability. The training and documentation available are superb. We really spent 0 hours writing code for edge capabilities, 0 hours on architecture, authentication, or security. Most of our time was spent configuring and building the UI.
Yeah. What else? The development environment is much more complex than it used to be. Microservices, architectures, many UI technologies, etc. And Predix is much more a system of systems. Just in UI space, we encountered more than 10 different technologies or tools, such as Node.js, Polymer, AngularJS, among many others.
That's true. And because that nature of systems, there is a learning curve to go through. But once you go through that curve, the ability to leverage existing microservices and reuse other existing components gives Predix a significant advantage in terms of cycle time, technology, and cost. And one more thing.
Alexa, ask Predix status.
Relax. Your app is working fine.
We would like to thank George Vadasenu at GE Oil and Gas. George is an IT and software engineer based in Romania, and his contributions were key to complete this project.